Across the universe, majestic swirls of gas and dust paint the cosmos. These are nebulae, stellar nurseries where stars are born. Imagine a canvas of cosmic proportions, a breathtaking spectacle of creation. We're about to journey into the heart of these celestial clouds, to witness the fiery birth of stars. These brilliant spheres of light illuminate the universe. They are the building blocks of galaxies, the engines of energy and evolution. But where do these celestial giants come from? How do they ignite and illuminate the vast expanse of space? Prepare to be captivated by the epic tale of stars. From their fiery births to their dramatic deaths, we'll explore the incredible life cycle of these celestial wonders. Get ready to experience the universe in stunning 8K resolution. This is a journey you won't want to miss. Deep within these nebulae, a grand symphony of creation begins. Gravity, the architect of the cosmos, starts to draw the scattered particles of gas and dust together. Slowly at first, almost imperceptibly, these particles respond to gravity's invisible hand. They begin to clump together, their mutual attraction growing stronger as their density increases. Over eons, these clumps pull in more and more surrounding material. The nebula, once a serene canvas of cosmic dust, transforms into a chaotic dance of swirling gas and particles. As these clumps collapse inward, they spin, their rotation accelerating with the accumulating mass. This swirling motion further enhances gravity's pull, drawing even more material into the growing core. The heart of the collapsing cloud, once cold and dark, begins to heat up. The energy of countless particles colliding generates heat, igniting the core with a faint glow. This is the first hint of the star to come, a testament to the immense power being unleashed within the collapsing cloud. The protostar, still shrouded in its dusty cocoon, grows hotter and brighter. It's a battle against gravity, a fight for survival as the protostar pushes back against the relentless inward pull. The fate of the star hangs in the balance, dependent on the delicate interplay between gravity and the emerging forces within. As the protostar continues to contract, its core temperature and pressure skyrocket. The heat becomes so intense that it strips electrons from their atoms, creating a swirling sea of charged particles known as plasma. The protostar, no longer a passive recipient of gravity's pull, begins to fight back. It emits powerful jets of stellar material from its poles, blasting away surrounding dust and gas. These jets, traveling at incredible speeds, collide with the surrounding nebula, creating shock waves that ripple outward. They act as cosmic sculptors, clearing out vast cavities within the nebula and revealing the nascent star within. The protostar, now a beacon of energy, illuminates its surroundings, casting eerie shadows and illuminating the remnants of its dusty cradle. The surrounding nebula, once a uniform cloud, now bears the imprint of the protostar's birth. Vast, dark pillars of dust and gas stand in stark contrast to the brightly illuminated regions carved out by the stellar jets. This cosmic interplay of light and shadow creates a breathtaking spectacle, a testament to the awe-inspiring power of star formation. The protostar, fueled by the relentless crush of gravity, continues to heat up. Its core, a crucible of cosmic energy, inches closer to the critical temperature needed for nuclear fusion. The surrounding gas and dust, sculpted by the protostar's powerful winds, begin to dissipate, revealing the nascent star within. Deep within the protostar's core, a fundamental transformation is about to occur. The temperature and pressure reach a critical point, igniting the engine of nuclear fusion. Hydrogen atoms, the simplest and most abundant element in the universe, are forced together under unimaginable pressure. They fuse, creating helium and releasing an incredible amount of energy in the process. This energy, born from the heart of the star, surges outward, pushing against the relentless crush of gravity. A star is born, a celestial inferno powered by nuclear fusion. Within the stellar core, a cosmic ballet of unimaginable power unfolds. Hydrogen atoms collide and fuse, forging helium and releasing energy. This energy radiates outward, illuminating the cosmos and warming planets. The star shines with its own light, a beacon of stability in space. Its surface churns and roils, driven by immense energy within. Energy travels outward, first through the radiative zone, then it reaches the convective zone, where superheated plasma rises and falls. This dance of energy transport ensures the star's luminosity for millions of years. The star's influence extends far beyond its fiery sphere. Its light and heat shape the surrounding protoplanetary disk, where planets are born. The star's energy influences the types of planets that can form and the potential for life. Having ignited its nuclear furnace, the star enters the main sequence, a period of stability and equilibrium. This is the prime of a star's life. a time when the outward pressure from nuclear fusion perfectly counterbalances the inward pull of gravity. This delicate balance, this cosmic dance between creation and destruction, defines the main sequence and determines a star's fate. The main sequence is not a uniform state, but rather a spectrum of stellar diversity. A star's mass, the amount of material it gathers during its formation, dictates its position on this celestial highway. Massive stars, colossal furnaces of nuclear fusion, blaze brightly but live short, intense lives. Smaller stars, more frugal with their fuel, shine dimly but endure for billions of years. Throughout their main sequence lifetimes, stars slowly exhaust their hydrogen fuel, their cores gradually converting to helium. This slow transformation, this cosmic clock ticking away, sets the stage for the star's eventual demise. The main sequence, though a period of relative stability, is but a fleeting chapter in the grand story of a star's life. As a star nears the end of its main sequence life, the balance between gravity and nuclear fusion begins to shift. The star's core, now depleted of hydrogen, contracts under its own gravity, while its outer layers expand and cool, heralding the beginning of its final act. The stage is set for a dramatic transformation, a celestial spectacle that will determine the star's ultimate fate. The universe is teeming with a dazzling array of stars, each with its own unique story to tell. From the fiery blue giants, burning bright but short-lived, to the faint red dwarfs, slowly sipping their fuel over billions of years, the cosmos is a tapestry woven with stellar diversity. This diversity, this cosmic spectrum of light and energy, is a testament to the intricate processes that govern star formation. Red giants, bloated stars nearing the end of their lives, loom large in the cosmos, their cool extended atmospheres hinting at their impending demise. White dwarfs, the remnants of stars like our sun, shine with a faint ghostly light, their dense cores cooling over eons. Neutron stars, the collapsed cores of massive stars, spin rapidly, emitting beams of radiation that sweep across the cosmos like celestial lighthouses. Stars do not always exist in isolation. Binary star systems where two stars are locked in a gravitational dance are common throughout the universe. These stellar companions can influence each other's evolution, exchanging mass, altering their lifespans, and even triggering dramatic events like supernova explosions. The vastness of space is filled with these stellar wonders, each a testament to the power of gravity, nuclear fusion, and the intricate dance of cosmic evolution. Understanding the diversity of stars, their life cycles, and their interactions allows us to unravel the secrets of our universe and our place within it. Stars are not merely scattered randomly throughout the cosmos. They congregate in vast, swirling collections known as galaxies, held together by their mutual gravitational attraction. These galaxies, islands of light in the vast cosmic ocean, are the stage upon which the drama of stellar evolution unfolds. Stars are the lifeblood of galaxies, their energy shaping the interstellar medium, the vast clouds of gas and dust that permeate galactic space. The birth and death of stars drive the cycle of galactic evolution, enriching the interstellar medium with heavy elements, seeding the formation of new stars, and sculpting the galactic landscape. The explosive deaths of massive stars, known as supernovae, are among the most powerful events in the universe. These cataclysmic explosions release enormous amounts of energy, forging heavy elements, dispersing them throughout the galaxy, and triggering the birth of new stars. Galaxies are dynamic, ever-evolving systems, shaped by the life and death of stars. Understanding the interplay between stars and their galactic environments is crucial to unraveling the mysteries of galaxy formation and evolution. Each star, from the smallest red dwarf to the most massive blue giant, plays a vital role in the grand cosmic tapestry. Even stars, those seemingly eternal beacons of light, are not immune to the passage of time. As stars age, their internal furnaces begin to sputter, their fuel reserves dwindling after millions, even billions of years. The delicate balance between gravity and nuclear fusion, maintained for so long, begins to falter, setting the stage for a star's final act. Deep within the stellar core, the once abundant hydrogen fuel has been consumed, replaced by an inert core of helium ash. With fusion sputtering, the outward pressure wanes, unable to hold back the relentless crush of gravity. The core contracts, heating up under the immense pressure, while the star's outer layers expand outward, transforming the star into a red giant. The once familiar star, now a bloated giant, casts a deep red hue across the cosmos. Its surface, a turbulent sea of plasma, pulsates and churns as the star struggles to maintain equilibrium. Planets, once orbiting at a safe distance, are engulfed by the expanding stellar atmosphere, their existence extinguished in the fiery embrace of their dying sun. This dramatic transformation marks the beginning of a star's descent from the main sequence, a harbinger of its inevitable demise. The star's fate, the path it takes toward oblivion, is intricately tied to its mass, the defining characteristic that has shaped its entire life cycle. Section 2. Stellar Metamorphosis, from Giants to Ghosts. For stars like our Sun, the journey toward death is a gradual process of shedding and transformation. As the red giant phase progresses, the star's outer layers become increasingly unstable, eventually detaching from the core and drifting away into space. This ejected material, illuminated by the fading glow of the stellar core, forms a breathtaking cosmic spectacle, a planetary nebula. These planetary nebulae, misnamed for their resemblance to planets in early telescopes, are anything but planetary. They are the death shrouds of stars, glowing testaments to the final breaths of stellar evolution. Within these intricate clouds of gas and dust, elements forged within the star's core are scattered into the interstellar medium, enriching the cosmos with the building blocks of future generations of stars and planets. At the heart of the fading planetary nebula lies the stellar remnant, a white dwarf. This dense, Earth-sized object is the exposed core of the former star, composed mostly of carbon and oxygen. It no longer generates energy through fusion, but radiates its residual heat into space, slowly cooling over billions of years. The white dwarf, a ghostly echo of its former glory, marks the end of the line for low-mass stars. It fades from view, a silent testament to the relentless march of cosmic time. But for more massive stars, the journey to oblivion is far more explosive and profound. Section 3. Supernova, the blaze of glory. For stars significantly more massive than our Sun, the end comes in a blinding flash of light, a supernova explosion. These cosmic cataclysms, among the most powerful events in the universe, occur when a massive star exhausts its nuclear fuel and can no longer support its own weight. With fusion extinguished, the core collapses in on itself at an astonishing speed, reaching unimaginable temperatures and pressures. This collapse triggers a runaway chain reaction, forging heavier elements like gold, platinum, and uranium in a matter of seconds. The energy released in this process is staggering, briefly outshining the combined light of billions of stars. The core's implosion rebounds, sending a shockwave hurtling outward through the star's layers. This shockwave, traveling at nearly the speed of light, tears the star apart, scattering its enriched material across vast distances of space. The supernova explosion, visible across the cosmos, announces the star's violent death and the birth of new elements essential for life. In the aftermath of this cosmic cataclysm, the supernova remnants, enriched with the building blocks of planets and life itself, expand outward, seeding the interstellar medium. These remnants, glowing with the dying embers of the explosion, will eventually give rise to new generations of stars and planetary systems, continuing the cycle of cosmic evolution. Section 4. Cosmic Echoes, the Legacy of Stars. The death of a star, whether a quiet fade into oblivion or a spectacular supernova explosion, is not the end, but a transformation. The material scattered by these events, enriched with heavy elements forged in stellar cores, becomes the raw material for new stars, planets, and even life itself. Nebulae, those vast stellar nurseries, are enriched by the remnants of past supernovae, their swirling clouds of gas and dust, seeded with the heavy elements necessary for planet formation and the emergence of life. Our own solar system, born from such a nebula billions of years ago, bears witness to this cosmic cycle of life and death. The atoms in our bodies, the iron in our blood, the calcium in our bones, were all forged in the fiery hearts of stars that lived and died long ago. We are, in a very real sense, stardust, connected to the cosmos through this intricate web of stellar evolution. The epic journey of stars, from their fiery births to their dramatic deaths, is a story that continues to unfold across the universe. Each star, a unique character in this grand cosmic drama, leaves its mark on the cosmos, shaping the destiny of galaxies and contributing to the rich tapestry of the universe we call home. The cosmic circle of life. From the smallest atoms to the largest galaxies, the universe is in a constant state of flux. Stars play a pivotal role in this grand cosmic ballet. They are the engines of evolution, the architects of the elements. The birth, life, and death of stars are interconnected chapters in the cosmos. The material scattered by dying stars seeds the interstellar medium, giving rise to new stars and planetary systems. This cosmic circle of life ensures the continued evolution of the universe. As we gaze up at the stars, we witness the echoes of creation. The atoms in our bodies were forged in the hearts of these celestial giants. We are children of the stars, our existence intertwined with their journeys. The story of the stars is also our story, a tale of creation and interconnectedness. So the next time you look up at the night sky, marvel at the grand cosmic drama unfolding above us.